Hi guys, so today we are going to learn how to find the line of best fit of scattered data, and we're going to learn how to use Excel to find that line of best fit, to find the equation, and to find the R, which is what we call the correlation coefficient. And as you know, the correlation coefficient is the one that tells us how well is my data, my line fit my data. So we're going to use Excel because Excel is something that's used in colleges, universities. It's available if you have Microsoft Office, and it's easier to use than any other technology out there. So what we're looking here, we're looking at a line of best fit. So we're looking for an equation of a line of best fit. A line, it's a straight line, and its equation is y equals mx plus b, where m is the slope of the equation and b is the y-intercept. And the closer the R value to 1, the better the fit is. So when you use Excel, Excel is going to give you R squared. Okay, and in order for you, so we call that a coefficient of determination, R squared. But we are looking for R. And to find R, which is the correlation coefficient, you need to take the square root of the R squared in order for you to find R. And then the closer R is to 1, the better the fit. And also, if you have a line that's going up, as you can see in this graph right here, since your line is going upward and then it has a 0.99, we know it's a positive correlation. It's a positive and it's a strong correlation. So we can say that this one has a very strong positive correlation. So very strong positive correlation, which means the points on the scatter plot form an almost perfectly straight line. All right. Now, if I have points that are going downward, I find my equation, which is y equal, in this case, negative 1.06x plus 20.91 with an R squared of 0.78. So what I need to do, I need to take the square root of the 0.78, and that's going to be 0.88. Now, when you get that answer, you have to make sure that it's negative 0.88 because it's going down. So it's a negative correlation. And the negative 0.88 is not as close to negative 1 as the negative 0.99. So the scatter plot has a weaker and negative linear correlation. So the points on the scatter plot are more spread apart, so as you can see in this graph. So the thing that you have to be careful with, that if your line is going down, you're going to have to make sure that when you find the square root of the R squared, the answer is a negative answer and not a positive one. Now, what we're going to do, I'm going to show you how to graph this and how to include a scatter plot. Okay, so we are going to take these points. So this is Liam collects data on a person's heart rate and the number of minutes spent riding a stationary bike at a constant speed. So we have the amount of time riding the bike in minutes and the heart rate beats per minute. So what I did is I copied these to Excel. And so I copied them to Excel, and now we are going to graph. Okay, so I'm going to show you how to graph a scatter plot. So if you're going to highlight the points, and then you're going to insert, and then you're going to go to the scatter plot, and then make sure you pick the scatter plot, please. In the other assignments, I've seen people picking the other ones. I don't want the other ones. When you're picking, don't pick this one, don't pick this one, don't pick any of these ones. Just pick the scatter plot, please. All right, so this is the graph, as you can see. Make sure that that you include, let me just make it a little bit bigger. I don't know what's going on with my mouse here. All right, so let's see where I can find. So chart design, and then you can add chart element, and you can add axis title. You can pick both of them. Oops, I picked, I guess. So the horizontal and the vertical, okay? So we added them. So we know that this is the heart rate. So make sure that you include, and what was it in heart rate? Beats per minute. And this one, it's going to be time and minutes. All right, and then you can choose a nice title to your graph. You can say the heartbeats when writing whatever it was. I don't remember what the question is. All right, so now I have the graph. Now I did include the axis title, which is important. Now I also have to include a trend line. So you're gonna press on the points, any point, just pick one point and press on it, and then right click and add trend line. Okay, when you add trend line, you're gonna pick the linear because we're looking for the line of best fit. So you're gonna pick linear, and then you're gonna say display equation on chart and display R squared value on chart. Make sure that you do press these two buttons here at the bottom. And then you are going to, I'm just gonna move the equation so I can see it. You can make it bigger if you want. Can't see this, come on. Okay, I don't know what's going on here. There you go. Nope, it's not allowing me to make it bigger, but I have the equation here. Now, if you want to copy this equation and you want to copy this graph, so if you have a MacBook, you can do Command-Shift-4, and then you can take a screenshot. Or if you have another type of another type of computer like Microsoft, Google Chrome, or whatever, you can look for the snipping tool and then search for the snipping tool and use the snipping tool to graph this. All right, so what I can see here is that it should be exactly similar to this one. So you can see on my Excel, I can't really, let me just do this, here we go. 1.4273x plus 74.545 with an R squared of 0.9642. What they have here is something that's very similar, but rounded. Okay, so they have something very similar but rounded. Now, basically, that's my equation. Y equals 1.43x plus 74.55 with an R square of 0.96. Now I still have to find the R value. So I'm gonna have to square root 0.96, and that would give me a 0.98. Because my graph is moving upward, it's a positive, and it's a very strong positive correlation, okay? Because it's a positive 0.98. All right, so this is how you do this in Excel. Now, another thing, that if they give you a graph and they give you the equation and they give you the R square, they could ask you, for example, what we have here is temperature and ice cream sales, and we have a graph, and we can see that as the temperature increases, the ice cream sale increase. Perfect. Now, what we're going to do here, the ice cream sale when the temperature is 25. So they're asking us to find the ice cream sale when the temperature is 25 degrees. So if we're looking at this graph right here, if we're looking at this graph right here, we know that the temperature is on the x-axis, and we know that the ice cream sale is on the y-axis. Okay, so temperature is on the x, ice cream sale is on the y. Because they gave me 25 degrees, which represents temperature, that's going to be x. So I'm going to replace x in the equation with the 25 degrees. And then I'm going to look for y. So that will be the number of sales. So y equals to whatever this is. So I can do BEDMAS, do the multiplication first, and then add 45.52. And my answer is going to be 82.27. Okay, so we have to multiply because this one, the ice cream sale times $10. So you see how it says on the y-axis, it's ice cream sale times 10. So that means if you get an answer of 82.27, you have to multiply that answer by 10 to give you the actual money, the value of the money that you have, that you sold. Okay. Now the second question is saying the temperature when the ice cream sale is 1200. So they want you to find the temperature. So they want you to find the temperature, which is in this case y, which is in this case x, because we said that the temperature is x, when the sale, which y, is equal to 1200. So remember that my equation is y equals 1.47x plus 45.52. In order to solve, so we know that y is 1200, so I'm going to replace y with 1200. And then I'm going to solve for x. So to solve for x, I'm going to have to isolate for it, and I have to do reverse BEDMAS. So the first thing I have to do is bring the 45 over as a subtraction using opposite operation. And that's going to give me 74.48. And then to solve for x, there's a multiplication between the 1.47 and the x, so I have to divide by 1.47, and that would give me x equals 50.67, which means that, what I missed and the mistake that I made is that instead of having 1,200, you have to divide it by 10, because remember that your y values are multiplied by 10. So basically my answer here should be, the y should be 120. I apologize for that. So this is telling you that the x value is 50.67, which means the temperature for a sale of $1,200, your temperature should be 50.67 degrees. Okay.